Take it away.
Okay, thanks a lot. I'll start now. So I'm going to talk about our experiences with running online multiplayer or group experiments. Um, so I'll give you a few examples of the kind of things that we've done, and hopefully you can still see my screen. So here is an example programmed. Oh, right, that's me on video as well. So here's an example of an experiment programmed by Sabine Topf, a PhD student at the department. And it's a game where a player walks around a town collecting coins, and walking around is quite tiresome, so the player needs to fill up on energy. There's two alternatives, an energy drink or an apple, and what the player can do as well is click on a map, and in this map, this is shared by multiple people playing the game. You can see what type of energy the other players have been using. Sorry that I'm not including a fancy video. Still trying to find out how that works in these kinds of slides. Anyway, the idea is that people in groups, and these groups can be 5 people or 10 people or even 20 people, they play the game and they can coordinate their behavior. And towards the end, I'm not going to talk too much about the objectives of this particular experiment, because I'll post a link where you can try it out for yourself towards the end as well. So this is quite an interactive game, all programmed in HTML and various things that I'll go into as well. Another example here, and this is not an experiment where people necessarily have to play it simultaneously, but this is more sequential, where what one participant sees depends on what people before him or her have done. So here it's about recycling, and the question is, where should you place this coffee cup, in the trash or in the recycle bin? And then the idea is that you can see what other people have put items in. So here you can see that someone put the coffee cup in the recycling bin. Often that's not actually what you should do. You should put it in a non-recyclable waste. But the idea is that we can see how people learn from each other and whether they convert in some way or another. Here is a final example of something that we are currently looking at. Here the player, again, this is one of these sequential tasks where the game builds on what other people have done before. Here a player starts at this place and is asked to visit one of these panda bears who, both of them are quite hungry, and you can bring them honey, and on the way there are hidden honey wells where you can collect more honey to give to the pandas, but you can see where other people have gone before. And then you can see these spots here where people have started to run around a little bit to collect more honey, and that might be a cue where to go. So again, this might be, well, the idea here is to look at how people coordinate their behavior from traces of other people's behavior. So these 3 experiments are examples where either the player or the participant is building upon what other people have done. So it's dynamic, but it's not necessarily that people are participating simultaneously, or it's actually a real-time simultaneous game where people are interacting at the same time. So the question is, well, why would you even bother? Because we've seen at the start the talk saying that, well, why not just deceive people and actually program things in that make it look like people are collaborating or playing at the same time, but it's not necessary. Well, deception is more straightforward. You don't have to do nasty programming. It's easier to run, and you also have tighter experimental control, which is something that is potentially of concern when you let people interact, because obviously then you let go of that experimental control. But why we chose to do it for real is that if you deceive people, there's limited ecological validity, and we're really interested in how people learn from each other and how behavior evolves over time in social settings. And for that, we really want to let that behavior evolve naturally. There's also the issue of contamination of the participant pool, and that's actually what they're quite concerned about in, for instance, economic research. If you deceive people and they realize, then next time around they might not believe you when you say that there's other people participating, even if, like us, you did the work and you made it actually so that it is really multiplayer. And another thing is that it's just not as much fun to not build these multiplayer experiments. And actually, it's not all that hard. So we heard Owen's talk before mentioning some of the frameworks that exist. There's lots of open open tools there, open source, free. I'm not going to go into the details. One thing that helped us is that someone from the local IT department was kind enough to set us up with a virtual machine running Ubuntu so that we could install an NGINX server as well as Node.js, which includes Socket, and that's a really important framework to allow these multiplayer interactions in real time using JavaScript. So just knowing JavaScript and HTML allows you to actually build these types of games. And it looks quite difficult at the start, but there's good tutorials online. And I think it is worth the effort. Now, obviously, if Gorilla comes up with a really good way to allow you to do multiplayer experiments, then that may be way easier. But these are some of the tool stack that we've used. Socket, really in brief, is just a way where on the server you run this Socket library, and on the client side there's a JavaScript library as well for Socket, and it just allows you from the client side, so the participant can send messages to the server, and the server can send these messages back, which are then received, and you can build interactions that way. So really, it is quite simple, and it just consists of these types of lines of code where on the client side, you might say, right, well, I'm ready to join the experiment. So you put in a JavaScript that just says socket emit, you emit a message with some data, and then the server receives that message, and then you can do something else, and it might say, oh, here, I'm happy for you to join this experiment, so I'm sending you this message back. And really, that is all there is to it, and it's not that hard, but you obviously need to test it out a little bit and be comfortable with a bit of JavaScript. So I'm just going to talk a little bit about some of the experiences, and unfortunately, there is something that's slightly missing on this slide. Anyway, the first example that I want to talk about is a classic economic game where people are asked to pick a number between 0 and 100, and they do this in a group. In our case, it was groups of 3 people, and the winner of the game is the person who chooses the number that's closest to, and it's here it should be 2/3 of the average of all picked numbers in the group. So the task of someone is to pick a number that's closest to 2/3 of the average of everyone's numbers. So that's quite a sort of a nasty, mind-bending thing to reason about. And if you reason about what people might be doing, you might think, oh, well, people will probably on average pick about 50, so I'm going to pick 2/3 of 50. But then if you think about, well, other people are clever as well, so they will pick 2/3 of 50, then I'm going to beat them, and I'm going to pick 2/3 of that. But then other people might be that clever as well. So you can see that if you follow that line of reasoning, the actual number should become closer and closer to 0. And that's what happens, but only if you let people play for a bit of time. And yes, the name, the beauty contest, is based on this quote by Keynes that I will get you to read in your own time, maybe at another point. So in our experiment, we had 2 stages because we were interested in allowing people to learn from observing what people in stage 1 did, or the advice that people in stage 1 gave. So we had 30 participants assigned into groups of 3, and they all played 4 consecutive rounds of this particular game. And after completing all the rounds, everything was recorded in their game. They were also asked to provide some advice to other players in later games. So here's what it looked like. It's quite simple. It's not the most beautiful game, but here is someone asked to provide a number. So the idea is to get to 2/3 of the average of everyone's numbers. Person provides a number and then has to wait for everyone else to make their choice, because then we can see who won the round. In this case, 60 wasn't that great. The average was actually 45, and the target value, 2/3 of that, would have been 30. So this person didn't win, but another person did, and they won actual money. So we do performance-related payout in these types of games, and then they could do it again, and they could see this feedback. In the later stage, we built upon what people did here, and there we had 60 participants randomly assigned to either an advice condition, where someone was given advice of a previous group, or an observation condition, where they could see what other groups have done. So here we are combining both the interactive sequential bit, where we are relying on what people have done before, as well as real-time interaction, where people are actually playing this game for real. Now, one of the tips that I wanted to give is the issue of to avoid dropout. So there are always people that can't be bothered finishing an experiment, or perhaps they accidentally refresh it, or they have to leave, so they close their computer, and that would destroy the game for everyone who's playing, and that's something that we really needed to avoid. So we have built in lots of waiting rooms where at the start, people first provide their informed consent. If they don't consent, we don't need to consider them anyway. But then after their consent, they're assigned to a condition, and then this concept of a room where we join people to play the game. So they're waiting for the room to fill up. After a room fills up, everyone can read the instructions. But then at the end, we also provide some attention checks, always a good idea, but we have another waiting room. So we're waiting for everyone to finish the instructions. But then if someone decides not to play the game while they're reading the instruction, we can actually catch that, and we can allow someone else to join the room, fill it up again before everyone starts. Because once the game starts, someone leaving, and it has happened, will actually ruin it for everyone. You can't finish the game because one of the players is just gone. So that's the really tricky bit with running real multiplayer experiments, is avoiding people to drop out. And that's why we also give people these messages saying, please don't drop out. You're gonna ruin it for yourself, but also for all the other people in the game. So it's nice to use sites like Prolific, because it allows you to run lots of people at the same time, because they're pretty good at giving you a number of participants. Warn that people might have to wait for a while for these rooms to fill up, and if they have to wait, we allow them to do something else, and we give them an auditory feedback when the room is actually full, so that they can return to play the game. Dropout is a real issue, so put in lots of warnings, tell them that it's really bad for other players as well. And the other thing is to really mind the server, so you have to become a little bit of a systems administrator to do this kind of thing. So that's it. I think I did it really quickly, but I want to thank Sabine, because she's actually programmed most of these experiments and games. And if you'd like to, there's our website here, and you can try some of these games out. So they're running at the moment. Hopefully you can try it out with some of your friends or some of the other people playing here to get the experience. And if you want to get started doing this kind of thing, here are 2 links that I found reasonably useful. So thanks a lot for your attention.
Many thanks, Maarten. I'm really looking forward to the speaker's corner, where you and Miles can throw down over whether or not the deception versus online synchronous play is the best way to go. And
Yeah.
I hope to be there with popcorn and enjoying the fight. I'm sensitive to the fact that we're running just a little bit slow, and I should make sure that we give time for other speakers. So I'm going to encourage people to speak with you in the speakers corner, as
Sure.
well as the other speakers. And just thanks again. Really interesting talk. Fantastic.